So like I mentioned, most people look at MTHFR in isolation, and you really need to look at the whole methylation cycle if you want a better picture of how the body is functioning. So there are also other genes that play a massive role in methylation. Welcome to the Soaring Child Podcast, where parents of children with ADHD learn tips and tricks to help their child soar at home, at school, and in life. We feature interviews with experts, medical professionals, and parents just like you who are learning how to reduce ADHD symptoms using food and other natural strategies. Because children with ADHD deserve to soar just like every other child. I'm Dana Kay, your host. Hello, parents, and welcome back to another edition of the Soaring Child Podcast. This is part 2 of our 3-part series where we explore the intricate ways genetics intersect with ADHD. In our previous episode, we delved into how genetics influence ADHD, laying the foundation for today's discussion. So if you missed last week, make sure and go back and listen to that episode because I think you'll find it very helpful as a precursor to today's episode. So today we're diving deep into a topic that has got so much attention in recent years, which is MTHFR. It's often regarded as the poster child of ADHD and autism. But what is it? What is MTHFR and why does it hold such a significance in the realm of ADHD and autism? So in this episode, we are going to really dive deep into this complex issue. We're going to break down the science behind it, but most importantly, we're going to explore how understanding MTHFR can empower you as a parent to navigate the challenges of ADHD more effectively. So whether you have been with us for a while as a seasoned listener or joining us for the first time, grab a notepad, get comfortable, and together we are going to unravel the mysteries of MTHFR and uncover its role as a crucial piece of the puzzle in the world of ADHD and autism. So let's get started. Now, before we really discuss MTHFR, I want to explain a concept called methylation. So methylation is a crucial biochemical process that occurs in our bodies. It's involved in adding a tiny chemical group called a methyl group to certain molecules in our bodies, like DNA, like toxins that are floating around, like proteins, like neurotransmitters. And this addition of methyl groups can have a significant impact on how these molecules function. So hopefully that's simplified enough. Now, understanding why methylation is important is super critical in the context of ADHD. So it plays a vital role in regulating gene expression, which basically means it can turn genes on or turn genes off. Now, when it comes to ADHD, certain genes may be involved in its development, and methylation can influence how these genes behave or how these different processes in our body occur. Now, the methylation cycle is one of the most important cellular processes in your body, but a lot of the time it's so misunderstood and it's very, very complicated. Some of you may have heard of it, others may have not. But as I mentioned, it's this little group of organic compounds that are found in proteins in the body and are called methyl groups. They are sent to different parts of our body to do different things. So here are a few examples of a couple of things. The methylation of environmental toxins and toxic heavy metals such as mercury and lead and other things makes them water soluble. This means they can be taken out of the body in the urine. It also helps us make some of our neurotransmitters. It converts tryptophan to 5-HTP, which is a precursor to serotonin, which is our happy feel-good hormone in our body. It also transports dopamine, norepinephrine, and adrenaline. It converts norepinephrine to adrenaline, which is really important for, our kids' mental wellness, focus, attention, mood, behavior, everything. It converts serotonin to melatonin, which is our sleep hormone in our body. parts of our DNA in living cells are methylated to function. In humans, 60 to 90% of the DNA needs to be methylated for us to function. So methylation is very important in neural development, and it appears to be essential to long-term memory formation. The cells lining blood vessels must be methylated to repair them. And this is not where it stops. This is just a few of the things that it's responsible for. But I want to say that having one or two suboptimal, weaker versions of the genes that are part of the methylation cycle doesn't necessarily mean the overall cycle is suboptimal or not working properly. The cycle's overall efficiency is most important, which can override any individual gene result in this cycle. Just like I said in the first part of this series, it's not just about one gene mutation. It's about looking at the overall picture. So let's dive into some of the genes that affect methylation. Now, the first one is MTHFR. Okay, as I was talking about earlier, it's often regarded as the poster child of the methylation cycle because of the role it's thought to play in the prevalence of autism. Okay, a lot of you may have heard of this gene before, but most people look at it in isolation, and that doesn't help. You need to look at the whole methylation cycle, the whole detoxification pathways, everything as a whole. So in case you aren't super familiar with MTHFR, I just want to explain it a little bit more. It stands for methylene tetrahydrofolate reductase. Quite a mouthful. It's actually an enzyme in our body, and its role is pretty significant in the context of methylation, which we discussed earlier. So what does it do? It's involved in a specific step of the methylation process. It helps convert a molecule called 5,10-methylene tetrahydrofolate into another called 5-methyl tetrahydrofolate. Okay? Again, super complicated. And this conversion is crucial because it produces the active form of folate, which is a B vitamin, which is essential for various functions, including DNA synthesis and repair. Now, the reason MTHFR is relevant in discussions about ADHD and holistic health is that many individuals carry genetic variations in the MTHFR gene. And these variations can affect how efficiently the MTHFR enzyme works. And when it doesn't work optimally, it can lead to less effective methylation and potentially impact various bodily processes. As I mentioned earlier, methylation is critical for so many different processes. When we're looking at MTHFR, we're evaluating two mutations or SNPs, okay? Their respective results are cumulative. So it's possible to be optimal for one and not for the other. Being optimal for both is obviously the most desirable, while being suboptimal for both is most likely going to be the most detrimental to your MTHFR function. So we look at two. We look at C677T. This one has a stronger influence on the MTHFR function. And then the second one is called A129AC. As I said, the results are cumulative. And I just want to give you a quick understanding of how those gene mutations, when you add them together, may decrease the MTHFR enzyme activity. Okay, so for example, if you hold two variants in the C677T and no variants in the A1298C, your MTHFR enzyme activity is only functioning at 25%. Okay. If we hold one mutation in the C677T and one mutation in the A1298C, your MTHFR enzyme will be functioning at 48%. If you hold two normal C677T genes and one mutation in the A1298C, it will be functioning at 83%. Most kids that I do genetics on in my business usually fall within the 66% to 83% of functioning in this enzyme. It's actually very, very rare to get someone at 100% functioning. I think I've only seen, about 4 times where someone's 100% functioning. But you can see that if this is functioning at 25% or 48%, we need to give this process so much help. So if you have an MTHFR genetic mutation, okay, it impairs the body's ability to break down folic acid, which may lead to a buildup of folic acid in the body. And when excess folic acid is there, it can contribute to a range of health issues, including cognitive decline, mood and behavioral disorders, potentially even increase the growth rate of cancer cells. So the takeaway that you need to write down right now is if you have a mutation in the MTHFR, you should not eat packaged goods that are fortified with synthetic folic acid. That's usually found in rice, in pasta, cereal, bread, and some of the nutritional yeasts out there. Not all of them. Bragg, yes, is fortified with folic acid, so you don't want to be using that one. So that is the takeaway. I think there's 2 takeaways out of that one. That's the first one. The second is the results are cumulative. So look at those 2 different mutations and add them together to work out how much your MTHFR enzyme is functioning at. And, if you want, I might actually drop the table in the show notes below so you can actually look at your genetics and say, okay, well, I've got this mutation and not this mutation. That means my MTHFR is functioning at 88%. So that will help you out there. I'll drop that in the show notes below. So you're probably wondering, okay, if you've got this genetic mutation, what do you do? Usually the go-to is supplementing with something called methylfolate or 5-MTHF. But I want to say, don't rush out and buy this supplement without listening to the rest of this episode, because this version may actually not be good for you, even if you have these mutations, because that's what happens when people look at the gene in isolation and not look at the whole profile. So like I mentioned, most people look at MTHFR in isolation, and you really need to look at the whole methylation cycle if you want a better picture of how the body is functioning. So there are also other genes that play a massive role in methylation. For example, SHMT1, MTRR, MTR, and FUT2. They all play an important role. Now, before we dive into those other genes, let's start with one you might not have heard of, but it's really important, SHMT1. So what's the job of that? SHMT1 helps make an enzyme that turns one kind of an amino acid called serine into another kind called glycine. Now, amino acids are like the building blocks of our body, and glycine has a special role beyond just being a building block. We should care a little bit more about glycine. It's also a neurotransmitter, which is a fancy word for brain chemicals that helps our nerves talk to each other. Better communication between nerves can mean improvements in things like focus, mood, behavior, areas that can be tough for kids with ADHD. Now, if the SHMT1 gene isn't doing its right job, it could mess up this conversion from serine to glycine. That could lead to an imbalance in these brain chemicals, making ADHD symptoms worse. Knowing how SHMT1 works can give us a starting point for understanding how to manage ADHD more effectively. Now, before I mentioned with MTHFR that if you've got mutations, the go-to supplement is methylfolate or 5-MTHF. But if you or your child has a mutation in the SHMT1 gene, then this is not the case. Folinic acid could be a better option than methylfolate. Let's clarify what these substances are. So both folinic acid and methylfolate are forms of vitamin B9, which is crucial for many processes in the body, including the making of DNA and other genetic material. They also play a role in converting these amino acids, those building blocks that we were talking about earlier, from one form to another. Now, the SHMT1 gene helps convert that one amino serine into another glycine, as I was mentioned earlier. But if there's a mutation in this gene, this conversion process might not work as efficiently. This is where folinic acid comes in. Folinic acid is a more flexible form of vitamin B9 that can be easily converted into other forms the body needs, including the form that helps with this serine to glycine conversion. Methylfolate, on the other hand, is already in a finished form, and that means the body can't easily convert it into the form needed to help with serine to glycine conversion. So if you have a SHMT1 mutation, using folinic acid can offer a more versatile and effective approach to support these crucial processes. So by choosing folinic acid, you're giving your body more options to navigate around this mutation and potentially helping to balance neurotransmitters and manage ADHD symptoms more effectively. So the takeaway here is, if you have an SHMT1 mutation, using folinic acid instead of methylfolate is the better way to go. Now that we've talked about SHMT1 and its role turning serine into glycine, let's move on to another important gene, MTHFR. This one also has a big job in the body, especially when it comes to ADHD. So what's MTHFR all about? Simply put, I don't know if this topic can be simply put, but let's try and make it a little bit simpler. It helps make an enzyme that changes one kind of amino acid known as homocysteine into another one called methionine. Like glycine, methionine is more than just a building block. It helps create something called SAMe, another crucial molecule. Why is SAMe important? SAMe is like a helper that moves tiny groups of atoms to where the body needs them. This is super important for making brain chemicals, controlling how genes act, and even helping to get rid of toxins, all things that are really, really relevant in the world of ADHD. So if MTHFR isn't working, it can lead to too much homocysteine in the body. High levels of this amino acid are not good, and they've been linked to various health issues and can make ADHD symptoms worse by causing inflammation and cellular oxidative stress. You've heard me talk about inflammation exacerbates ADHD symptoms. So just like SHMT1, understanding how MTHFR works can give us more clues for managing ADHD symptoms more effectively. Knowing about both of these genes helps us see the bigger picture of what's going on in the body and how we can help. So we've looked at MTHFR, we've looked at SHMT1 and MTHFR. We're now going to turn our attention to another gene called MTR. This gene also helps turn homocysteine into methionine. Tongue tie there. This gene also turns homocysteine into methionine, just like MTHFR. But MTR has its own unique considerations, especially when it comes to vitamin B12. So if there's a mutation in this gene, it can affect how well the body handles certain forms of B12, specifically the methylated form known as methylcobalamin. Now, imagine your body's methylation process as a sink, okay? If you have a mutation in the MTR gene, using methylcobalamin is like clogging that sink. Your body can start over-methylating, making it clogged and not very happy. And this can obviously worsen ADHD symptoms by causing inflammation and cellular oxidative stress. So what's the solution in this case? Something called adenosylcobalamin. It's a non-methylated form of B12 and it's often recommended. It's like using a type of soap that won't clog your sink, allowing everything to flow smoothly. So adenosylcobalamin gives the MTR enzyme the support it needs without the risk of over-methylating, making it a valuable part of a personalized ADHD management strategy. Okay. So we're navigating through this genetic landscape of MTHFR and ADHD. We've looked at MTHFR, SHMT1, MTRR, MTR, and then we're going to bring in another essential player, now into this spotlight. So this is called FUT2. This gene has a unique role, especially when it comes to the absorption of vitamin B12, which is a cornerstone of the methylation process. So we've talked about which form of B12 might be good for you based on whether or not you have a mutation, but now we need to look at, can we absorb it? This gene helps determine how efficiently your body absorbs B12 from your diet or supplements. A mutation in the FUT2 gene can mean your body isn't good at soaking up this vital nutrient. Why is this critical? Okay, vitamin B12 is like a linchpin in the methylation process. Methylation is like the body's fine-tuning system, and B12 is like one of those knobs. If you're low on B12 due to a FUT2 mutation or an MTR mutation or whatever it may be, your body's methylation process could be out of whack, potentially exacerbating ADHD symptoms. So think of FUT2 mutation as a bottleneck in a supply chain. If B12 can't get through efficiently, the whole methylation process can slow down or become imbalanced. So understanding your FUT2 status can help you fine-tune your B12 supplementation, ensuring that the methylation process runs smoothly. So what do you do if you have a mutation in the FUT2 gene? This is the takeaway from this section of the podcast. Firstly, you need to know if you need B12 in the first place by checking your B12 levels by a blood test, but also checking if your homocysteine levels are high, because if they are, you need B12 to help that conversion process, as I mentioned in the MTR and the MTHFR genes. Then, if you do need B12, you need to bypass the gut absorption of B12 by taking a liposomal version, which means under the tongue. So you can get a liposomal lozenge or a liposomal liquid, or you can get an IV directly into the bloodstream. Now, that's a bit more extreme. And, if you really, really have an overload of homocysteine or you're really, really deficient in B12 and you've got this FUT2 mutation, your practitioner might suggest an IV dose. Otherwise, finding a liposomal version under the tongue can be a great way. So we're looking at, can you absorb it? And, if you start taking B12 supplements in the form of a capsule or a tablet and you've got a mutation in this gene, you're not going to be able to absorb it in the gut. That's why taking a liposomal version will help much better with the absorption. Wow, that was a jam-packed episode. I hope you understood it. I tried to really simplify it as much as possible, and just want to thank you guys. If you've stuck with me to the end, thank you for taking this deep dive into the world of methylation and ADHD and genetics. You've probably heard a lot about MTHFR when it comes to ADHD and autism. Well, today we've gone beyond that one gene to look at those other big players, SHMT1, MTRR, MTR, and FUT2. They also have a huge impact on the whole methylation cycle and obviously managing ADHD. So if you guys have got any questions at all, send me an email, drop me a PM on social media. Really understanding these genes can really help you tailor your approach to managing ADHD. It's like having a personalized roadmap to help you navigate through the ups and downs of ADHD. Knowledge is power. The more you know about yours or your child's genes, the better choices you can make. And as always, make sure to chat with your health practitioner for advice that's tailored just for you. If this episode has been helpful, I would love to ask if you could please do me a huge favor. Share it with anyone who could benefit. And don't forget to hit that subscribe button so you won't miss out on future episodes packed with tips and strategies for thriving with ADHD. Now, remember, this is part 2 of that 3-part series. Next week is part 3. You don't want to miss out on it. So mark your calendars for next week, and I hope that you can tune in. Thank you for joining me on this week's episode of the Soaring Child Podcast. I'm Dana Kay, your ADHD health practitioner. Keep on thriving. Thank you for listening to the Soaring Child Podcast today. To learn more about how to help your child with ADHD soar using natural strategies, visit our website at ADHDThriveInstitute.com and follow us on social media at ADHD Thrive Institute.